I'm using the online calculator but I'm not sharing it, but I think y'all can do it too. Okay, so the men, the number of men is 94, and I think they use 1.0, but it doesn't really matter because this is in the millions. And then the women was the 13.7 plus, just add those up.
101.
Yeah, that sounds right, but I'm going to make sure.
Yeah. No, definitely.
Every time I don't be sure, I'm sorry. And I mean, that doesn't mean I don't trust anybody, but last night I had a...
No, I could be wrong.
And it's not just you, it's me doing silly stuff because, 101. Last night, I actually downloaded, I can't remember what it was now. It was one, and I just downloaded it into, it was that expected value. I downloaded it into Excel so I wouldn't make any mistakes. And I checked, did it so that I could write it on the board. Well, I evidently, when I was writing it on the board, I put a 0 in the wrong spot, and then everybody was looking at me. So, and now what was on the problem? So,
yeah.
All right. So you got to double check things. So then if you add them up, it's 195, right?
Yes.
And so we use the number, the women, the 101 over 195.
And okay, so that's when you lost me. Why would you do that?
How many women are there?
101.
Okay. So 101 over 195. You got to think of these as like say all of these cards. These are, and there's 195 million of them to make it easy. And they've all got their education level, one of those 5 or 6 education levels, and then it's got their gender on it. You go in and pull them out. Well, out of 195 of them, there's 101 in there. So that's what the probability is. In other words, the proportion.
The men's one. Why wouldn't you use the 94 over?
Well, we're doing women right here. See?
Oh, okay. Okay.
And then now we use the men.
Oh, okay. That's what I have written down, but I was just confused. I thought you just wanted us just to use 101 over 195, but I got that.
Well, I'm just filling in the formula. That's all.
Yes, I got it.
One step at a time.
Okay, I see it now.
So, and that's the men, and this is the women.
Yes.
Now, let's go back over here and look at this and find the ones that are both men and women. Now, in today's age, maybe it's possible for that to happen, but they don't have this on the data, right?
Yes.
There's nothing in here where there's both women and men. So I'll just put it back over here to let you see. There's no data here that has those that are both. Okay? Yeah. So what happens is this is mutually exclusive. So I could easily put a 0 there, and then that's just going to be 195 over 95. So the probability of going in here and pulling out either woman or man is actually 100%. We're going to get either a man or a woman.
Okay.
Now, they don't all have to add up to 1, but that's the most they can add up to. And this is hopefully helps illustrate that one of the reasons you're going to subtract things out is because sometimes if you don't, you could end up with probabilities that are greater than 1 and then invalid. So in this case, it doesn't happen, but all right, let's do, and it's associate's degree. Tell you what, I'm going to type it because it's quicker. I said woman, right? Yeah.
Yes.
And I'll just abbreviate it as AD. Okay, now, as we're going to get in, we'll just do it a step at a time, and then hopefully we're going to see that these two things are not mutually exclusive. They can exist at the same time. So let's go back over there and look. We already know woman. Let's do the associate's degree one from that. All right, associate's degree would be both of these in this column here. You see that? Where my cursor's at? So that's 7.2 and 9.6. So that's 16.8. All right. So now let's just go back over. We got everything we need now because we already collected or did part of the problem in the previous one. So here, this is 16.8 over 195. And then the probability of woman is 101. Now, let's go back over and look at that data because it is possible to have an associate's degree and be a woman. So let's find that number. Well,
and whenever you see and, that means times, right?
Well, for multiplication, but
not for this problem. We wouldn't put it in.
There are probably situations where you could calculate the data like that, but I doubt that you're going to have that within the context of this course. But that's essentially what you're looking for is the ones that have both qualities.
Okay.
Both qualities. So we don't need to multiply to find the and because if we go to because it's right there. See, associate's degree and woman is 9.6.
So we don't have to do anything.
Right. So 9.6 is what's going to go over there, and we'll just go over the same denominator. Now that's the and thing right here. That's this. That's that right there. It's the ones that are both. I'm sorry. Well, it's this one, actually. That's the ones that have an associate's degree, and they're also a woman. Now tell me, why do I have to subtract those out? My probability won't be accurate if I don't subtract them out. Why do I have to subtract them out?
Because it's going to overlap it.
Well, but just more specifically, in more general terms, maybe it took me a while to figure this out, so I'm not saying that. That 9.6 is counted twice. It's counted in the addition of the women, and it's also counted in the addition of the associate's degree. So we can't count it twice. So that's why we subtract it out. We're subtracting out the overlap. All right?
Okay.
So that's why we do that. So then that's going to be, let's see, I'll just do it on here. So it's 16.8 plus 101, 17.8 minus So that's 108.2. Is that right?
I got a decimal. I got a 0.5548, so I must have did it wrong. Hold on.
This is 117.8 minus 9.6.
Oh, okay. I'm doing them together. That's why I'm getting it wrong.
So now
one.
we can
Yeah,
just,
I got it.
so that's, well, you got what? 0.555?
I got 0.5584.
Well, that's it as a decimal. That's right. So that's just a little over half. So 0.555 essentially if you round it off to 3 decimal places.
Okay.
Well, does that make it a little bit clearer? Because I mean, I wanted to do something where I hadn't used the data, previous data.
Yes, it did. Thank you so much.
All right. So what else we got? Anybody else got anything they want help with? I put some stuff in here. Maybe this might help wake y'all up here, because this is something that people have trouble with. So that's why I put it in here. It wasn't in here when we went over it before, but I put it in yesterday.
And
Before,
the multiplication rule is basically the same thing as division. Addition. You just multiplying them, right? When you set them up.
well, okay, you still find each individual one separately.
Yes.
But yeah, you multiply when you have and.
Okay.
Instead of and. And like I said, for or, there's 2 cases. It's where you have mutually exclusive and not mutually exclusive. Well, the same thing is true for and. They have, 3 different formulas, which you don't really need that if you understand it, because what happens when you have and is you either have independent events like die, you roll one die and you roll another die. Well, the first die doesn't affect the second die. And the example that I used to illustrate independence and dependence was also the card, drawing a card from a 52 card deck. If you draw in 2 cards and you want to find the probability of getting this and that, or then what you do is if you don't take the card, if you don't put the card back, you let the first person keep the card, then the denominator and possibly the numerator will change on the second pick on the probability of B. Now, if they're independent, then you don't have to worry about that. But that's kind of the same situation for that you have for or. They're very similar. They both have that one, kind of subset, mutually exclusive and not mutually exclusive. Well, over here, it's independent and dependent and independent.
Okay.
But like I said, you can do everything with this one rule here. You just got to realize if they're dependent, then that second pick is affected. Like I said, the best example I can think of is a deck of cards. If you have doing 2 picks and you want to find the probability of a king and a king, then if you put them back in there, then it's always 1 over 52. I mean, not 1 over 50, 4 over 52, which is 1/13. But if you don't put it back in and make it dependent, then on the second pick, on the first pick, it's the same thing. It's 4 out of the 52 are kings. But on the second pick, you got to assume that there was a king taken, because you need 2 of them. So on the second pick, both the numerator and the denominator are affected. you have 51 cards in there for the denominator, and in the numerator you have 3 kings. But if there's a replacement, then you don't really need that. You don't need the dependence. The dependence is not there. I was going to show you what I put in here for 5.5. Okay, that's the binomial formula, which I mean, you can do it by hand, and if you really want to. And like I said, it's always good to do maybe one if you can, but it's really tough to do it because to do something that's more practical, it's just not really easy to do. But all of the ways that you can set these up, they'll fall into 3 categories. All right, this is the one. It's usually exactly, but it could also be used with equal. I know one of the problems in the homework, it had find the probability and it just had a 3 in there. Well, that's what that means. This one, is going to be now you got to kind of just remember that both of those, essentially, those 2 examples mean the same thing. All right. If you were doing a calculation and we had values for P and N, then both of those things that I have there, find 3 or fewer or less than 4, both of those the endpoint would start at 3. Okay, because only the first one includes the 3. The second one is saying less than 4, which starts at 3. And this one is usually stuff like at most. Wait a second. Let's just do that. Greater than 6. So both of those essentially mean the same thing. Now, if anybody's got a problem that they are struggling on that, this would be a good time to give it to me, because I can show you a little tool that hopefully will illustrate this a little bit better. Anybody have any of these worked on? I had a few people send me questions over when I got back Monday. Well, actually, I think there was somebody that sent one Friday, and then I saw someone Monday, but I'll try to find one then. All right. Let's see what we can get here. So this would be 5.2. And I just was realizing last night when I was looking in the other class, some of these dates, I guess they're all right. I don't know. They're awful like stacked together. I mean, I didn't make any 2 on the 4th of July, but we're essentially at the midterm point. I mean, it ends today, or I don't know, or in the morning or whatever. So that means we got 4 chapters to go over. Now, the good news is there's not a whole lot to 11, but 6, 7, and 8 can be a mouthful, especially 6. But there's also, I'll try to help you when we get past that, because as long as you get through chapter 6 knowing basic stuff, you should be able to do 7. All right, so let's see. What was I going to do? I was going to find 5.2 and find 1. And we'll kind of go through and try to explain these to you. Let's see if we can find a good one. I think there's like 8 or 9 or something like that. All right, yeah, here's a good one. Big babies. All right, so this talks about a public health organization reports that 30% of babies, and the age range is not that important for the calculations, but 6 to 8 months old weigh more than 20 pounds. A sample of 14 babies is studied. Round the answers to 3 decimal points. Now, the important information in here is the 30%, which is going to have to be written as a decimal, and then the sample of 14, because that's your trials. So I'll type it up here. So n was equal to 8, I believe. Was that what it was? No, it was 14. All right, so there's your 30%. You're going to have to work with it as a decimal, because that's just the way that math is. That's why you convert to percents, because it's usually easier for people to understand. But calculations with percents can get, or at least anything advanced can get. And I got probability spelled wrong there, but all right. So let's go back over here, and there was let's see if there's some kind of identifier on this. This is 5.236. So this is just out of that homework in 5.2. Now, and there were several parts. There's an A. And what the A was, I'll take you back over there and let you see it. What is the probability that exactly 6 of them will weigh more than 20 pounds? Now, you don't have to worry about the 20, because the 20 is the same throughout. So that one is, you're just talking about 20-pound babies here. The 20 isn't used. The only thing that's important is the 6. All right. So for A, it's find so when you see that exactly or equal to, then you just find in one value. Now we're just going to go over in the calculator and do it, but what you're going to be using is I think it's, let's see, what is it called? Let me just make sure I got it right. In the calculator, it's, if you can do it in Excel, you can do it in all kinds of places. It's binom PDF. And it's pretty much got the same name in Excel. And then what do you put in? Well, the first thing you put in is the n, which is the 14. The next thing you put in is that probability. You can put 0.3 is sufficient. And then you put 6. Well, what's that equal to? I think they said round to 3 decimal places. All right. I'll show you on the calculator. And then I'm going to show you on this little website. All right, so let's clear it up. The way you get into where that binomial PDF is you hit second, and then you hit vars. And then that gives you, it says DISTR. There are several different distributions. We're not going to use all of those. Really, the only ones we use are, in chapter 6, you use 2, 3, 4, and maybe 5 or 6. Actually, I think the 5 and 6 is from chapter 7, chapter 8, but the one we want to use now is way down here. All right, and it's the one that's right after the 0 one, which would be the 10th. So that one, it's labeled as A, but it's the 11th one. So you hit enter, and then you put in the trials, which was 14. You put in the probability of 0.3, and then we put in the 6. And we hit enter a couple of times. 0.12620222741. Now it said round off to 3, so it would be 0.126. All right, let me show you. Anybody got any questions about how I did that before we? Did they catch on to what we did? As long as you know where that's out, that's the way to do it. That the book will show you. They have it in there. You can also go on Google and just put in TI. And even if you don't have the TI 84 Plus, because I hate to make people go out and buy a calculator when there's so many things that you can use to do this. So if you got an older one, I remember somebody had mentioned that, it might have been another class, that if you have an older one, you can just go to Google, put in the name of the calculator, and then put what you want to do, like binomial formula. And then you'll get the instructions at some point. You probably get tons of them. All right, so let's go over and we'll do this little site that I got here.
And just right quick, I have a different type of question. It's the same stuff though. It's on this. This one, it says, what is the probability that more than 18 of them? So
there's that on that problem. Let me go back over there.
Because I know with 18 you have 1 minus and then the binomial stuff, but I can't get the same answer that I got.
Well, we're going to go through. See, there's 4 parts to this. Yes. All right. So we're going to go through all of them. All right.
Oh, okay. I was just making sure. Okay, that's fine.
Okay, because I'm just assuming that because I'm kind of trying to explain from the context that there's 3 different ones.
Yeah, that's what I was hoping that you was going to go through all of them, but
okay. Wait. All right. So now let's use this little thing. And that's one reason why I'm going to show you what I'm showing you now, because this little thing essentially will do all of them at the same time. The ones that you're talking about. So, and clear that out. And there's the site I'm using. It's called StatTrack. And you're still going to have to give it the three different things. If you're doing it by hand, you know, you got to do the subtraction of the p yourself, and you got to take the exponents. But since this site is, you know, it's a program, it's got all this built in. So you just have to give it those three things. All right. Now, it's called a binomial probability calculator, and that's the link for it. Let my computer catch up here. All right. So now, as we said, back on the board, I had, what was it? It was the probability of success was 0.3. The number of trials was 14. And the number of successes was 6. All right, now notice they got 5 different ones, and they're going to give you, they don't know which one you're going to need, so they're going to give you all of them. All right, so there's the one right there for the exactly 6. 0.126. You see, it's the exact same thing. Now, what these other ones give you is they give you the less than. So this would be everything from 0 up to 5, because notice that here there is no equal sign. All right. And now if you include 6, then it's going to be 0, 1, 2, 3, 4, 5, and 6. So that's why it's larger than this second one. Now, the last two are going the other way. That's the more than. All right. Now, this one right here is more than X. These two right here, let's see if I can kind of, it won't let me select two, but these two middle, this one and this one, these are complements of one another. Because if we have 0, 1, 2, 3, 4, 5, 6, then the complement, the more than 6, is 7, 8, 9, 10, 11, 12, 13, and 14. So this one and this one are complements. And if you take these two probabilities and add them up, then you will get 1. And that's why the complement rule works. The calculator is not smart enough to do all this for you, okay? I mean, I want to say it's smart, not smart enough. I can't say why they don't do it, but they probably could do this, but then I don't know if they feel that would be too much information or what. But this one and this one are complements of one another. Now this one right here, the first one that didn't have the equal sign, that was 0, 1, 2, 3, 4, 5, its complement is down here. And then that would be 6, 7, 8, 9, 10, 11, 12, 13, and 14. This one and that one are complements of one another. And you'll notice, if you take them and add those two up, you'll get 1. Again, that's why with the calculator, you have to use the complement rule, because they are essentially only doing these two. They only allow you to do these two. But they don't give you both. They're relying on you to know that whether it, when you're talking about less than or less than or equal to, whether it includes the endpoint. All right. So let's go on to the second problem in that. I had to go over and find out what it was, but because I can't remember now. All right. What is the probability? Okay, well, it's using 6 for all of them. So we already got all our answers. So for B, what is the probability that more than 6? More than 6. Now tell me, anybody, does that include 6? When you say more than 6? Think about that and answer it. Does that include 6?
No, it doesn't.
Yeah, if I say you got to give me more than $6, well, you're talking about whole number dollars, then you got to give me at least $7. And that would also include 7, 8, 9, 10, 11, 12, 13, and 14. All right. So this will be a good illustration. Now let's go back over and look at that thing again. Well, I'll tell you what, I'm going to write it on the board the way that, if you're doing it with a calculator. And you could also set it here that was X is equal to 6 probably. But I think usually they'll just have the number in there, 6. Now, you could also write this as y'all agree that those two things mean the same thing within the context of what we call discrete data? We're not worried about anything in between 6 and 7. We're only including whole numbers. So if we say greater than 6, then that's the same thing as saying greater than or equal to 7. All right? Now with the calculator, what we got to do is we got to do the complement rule. And we also have to use the CDF, the CDF. With the same values. And I'm going to do that for it, and I'm going to go back to that. Now, what we got to put here, though, is we got to put 7. All right? Because we want to include 7 in there. Whoops. I'm sorry. That would be if we're going the other way. So it's 6 because, remember, we're using the complement. Another way of looking at it is we want 7, 8, 9, 10 through 14. So then the complement is 6. So 6 is not included in there. So that's why we got to use the complement rule. And 6 is at the end point of that complement. So I'll do it both ways. Like I said, let's go do the calculator. And then, like I said, I'm going to go back to that other site. And I'm glad I picked the perfect problem here because of the fact that they're using all the same values. Now, like I said, you've got to put in this in order to figure it out. You could do it in 2 separate steps if you wanted to. Find it and subtract it from 1, but I'm trying to be a bit proactive. We got to use the CDF. So it was 14.3. And what did I say it was? I forgot. We got to use 6, yeah. So put the 6 in there, and then we hit enter a few times, 0.09328. All right, so let's go back over to that site that I sent you. See that right there? It's calculating it for you. All right, but if you would to take this, so this right here, this is the one that we just calculated on the calculator, the 0.09328, and that's what we got on the calculator by using the complement rule. So what the calculator did when we put in the binomial CDF and used the 6 in there, it was calculating this, and then because we put in 1 minus that, we were subtracting the point 9067 and getting this. All right. So that's how that more than works. Like I said, I don't know if it's any more clear because I haven't heard anybody say anything. But like I said, these two are complements of one another. So that's why we can use the complement rule. And the calculator, like I said, it's always going less than when it calculates. Whatever your endpoint is giving it, it's always essentially doing the less than or equal to. And whatever endpoint you're giving it is where it's starting, and it's going all the way down to 0 and it's adding them up. If you want a more than, you've got to do the subtraction because it doesn't do the more than for you. Same thing if you were doing it in Excel. You'd have to do that 1 minus, but that's easier in like Excel. But it's not too hard in the calculator either. So questions about that? That's a harder one, the more than, because like I said, you got to use the complement fact. All right, let's see. Oh, and I should have wrote it on there, but it was 0.09, whatever. So C was fewer than 6. So fewer than 6 also does not include 6. So that means that the endpoint that we put in for the calculator has to start with 5. Fewer than 6. If it had said 6 or less, or if, like I said, for B, if it had said 6 or more, it wouldn't be including, and then we have to, for the B, we'd have to take into account what the complement is. All right, so fewer than 6. I probably should have been doing this all along. All right, so the next one, it was fewer than 6. And like I said, you can write it more than one way. You could write it as X is less than 6, or you could write it as X is less than or equal to 5. Those both mean the same thing when we're talking about discrete, okay? Because the next number below 6 is 5. So this one doesn't need to complement because this is the way that the function works in Excel and most everywhere I've ever seen. But we're still doing CDF because we got more than one value there. We got 0, 1, 2, 3, 4, and 5. Now we can't put 6 there because if we did, it would include 6. All right. So let's do it with the calculator, and then I'll go back and show you on that little program. I mean, on that online program thing. So everything's going to be the same, but we can't keep a 6 there. We include the 6, and the specific instructions were fewer than 6. Because the calculator always uses the value you put in there as X as the endpoint when you're talking about CDF. 0.780515. And then if we also go back over to that program that I'm showing you, then that's that one right there. Oops. Then that one's right there. Again, there's no equal sign here. So it's not including 6. It's going to the next number down, which is 5. Okay. I think there might be one more. Another was something about rare or what. We'll do that one and we'll take a little bit of a break. And then the last one is a completely different number. So it's 8. And it's a more than. So again, we'll have to use the complement rule. Or like I said, we can use that other site. I'm just going to use that other site. But this would be the exact same thing as B, except you're just doing 8 instead of 6. So to make it quick, I'm going to go back over and just pop in an 8 on that thing. Should be changing any moment now. Come on. Is it really just that slow, or? There it goes. Yeah, it's just that slow. I'll tell you what, I'm just going to write it on here. Come on, come on. Reload this page, see if that helps. So the last question was, all right, so So like I said, if you wanted to do this one, you just do this exact same thing that I did for B, except you put an 8 where the 6 is at. So let's go over and look at that. If it doesn't switch over, I'm going to just... One more time here. All right, I'm just going to do the thing and then tell you what it is. Okay, it's finally going. All right, so I just changed the number of successes from 6 to 8. All right, and notice how small that number is. All right, and what's the answer? Is that unusual or not? And this is going to kind of be important in chapters 7 and 8. That 0.05 is where we draw the line of something being unusual or not. It's 5%. So when you get into 5% territory, which is outside of the 2 standard deviations of 95% with the empirical rule. All right, so let's take a little break, and I'll see you, I don't know, 10 or 15 minutes. What's that?
When we come back, could you just put something into that little website to see if you get the same answer? Because on this homework question, I'm trying to do it as practice, but every time I do it, I get the wrong answer. So when we come back, can you just show
on that site? On that site, you're saying?
Well, I'm doing it in my calculator because
okay, I got you.
But I keep getting the wrong thing.
Yeah, that sounds like that's a good idea. Okay, I'll do that. All right, folks, I'm back. All right, let's see. Did anybody ever show up? Let's see. Deja Martin. Let's see. Jamal's out there. I don't see Megan. Crystal Johnson. She already done her testing, huh? And then the first guy that never has showed. And Brittany Sampson. All right. All right. So, any other questions? I know you got one, Holland. I'm glad to go through it with you. I just want to make sure I don't. All right. So that was kind of the main thing I wanted to go over because, generally speaking, I have people have a hard time with it because usually the way I have concentrated on it before in the traditional classes is try to do it by hand, and like I said, it's really hard to do that with any kind of efficiency. So I wanted to just bring in the technology to do it because it's just not easy to do by hand. I mean, you're doing a bunch of calculations.
So the problem I have is I'm gonna just read it to you so we don't have to really pull it up and take too much more time.
Okay.
But it says, according to the recent report, 67% of internet searches in the particular month use Google search engine. Assume that the sample of 23 searches is studied. And it says round to at least 4 decimal places. So on this one, it says, what is the probability that more than 18 use Google? And I did it exactly how you showed me in the calculator and everything. And it gives me the answer of 0. Go ahead.
Okay. What was it? How great? More than what?
It's more than 18. So what is the probability that more than 18 of them use Google?
Okay.
Rocco, stop.
Does that make sense so far?
Yes, it does. Mm-hmm.
All right. I'm going to do it with the calculator. And I'm not.
Tell me what you get, because the answer on here is not, I don't know why. I don't know. Watch you get something different than me, though.
So we got 23. And then we got 0.76, right?
Yes.
And then we're going to do 17.
Oh, I'm sorry, 0.67. I'm sorry, 67.
Oh, okay.
I'm sorry about that.
Well, I probably heard it wrong, backwards.
Well, I probably said it backwards. I sometimes.
You would think they wouldn't allow teachers to be dyslexic, but I mean, I flip numbers all the time,
Yeah. Definitely when you're looking at them for so much.
All right. So I'll just go ahead and show you. So then 0.17.
You would put 17 for the problem you showed us before. You said that you would put 6 still.
What's that?
You would put 17 because the problem you showed us with the 6s before the break, you told us that if it's more than the number, then
wait a minute. Hold on a second. Yeah, I'm just going crazy here because I'm still taking a break.
No, you're
all right.
fine.
Watch. Let me show you something.
Okay.
I'm just going to write all these out because I think I fell from my own trap here. All right. Let me use different colors. Because this is, I mean, the wise way to do it is to go through and make sure you know what the complement is. Because if you make a too rash of a judgment, and I think that's what I did. All right. Oh, it won't let me do that like I want to. Well, I'll tell you what, I'll just do another one. All right. So let's see if we got this right. So greater than 18 are the ones in blue. Am I not correct this time?
No, you're correct.
Okay. So I think what I did is I was being too hasty, and like I said, it is. All right. So what we would have to do is include 18 there for the complement. I mean, for the more than. All right. So we would have to include 18. So I apologize for that. I just went too quick.
No, you're fine. I was just confused because I was like, okay, that's probably why I can't find my right answer. So.
But the smart way is what I'm doing now. And then, like I said, I try to appear smarter than I am. So I wanted to do it all in one shot. But this shows you that what's in blue is what you're looking for. This is what you're looking for, this right here. And you're going to do it based upon whatever this is. And you're going to find this and subtract from 1. And then what's left over would give you this, the ones in blue. So, so if we do it on the calculator, so it's 23. And I'm going to do it as 2 steps. Like I said, I'm trying to bite off a bunch at one time, which is why I'm doing the 1 minus in the calculator. If you do it bite by bite, like I said, it's you have a little bit less chance of mistakes. Okay. So now let's just put that in the calculator. And I'm just going to do it in 2 steps. And then I'll so it's down to the same 1, the second binomial thing. And then, like I said, it's 18. All right. because it said more than 18. So on the complement, we got to include the 18. Okay, so it's 1 minus 0.9999. And I'll show it to you also over here on that little program. The good thing about the little slide I sent you, it does both for you. All right, so it's 0.99. .919. Because we're going to 3 decimal places, if I remember. So as so it's 0.081. I'm sorry. So there we go.
Okay, so here's the problem. Maybe because I was working on the homework with a friend, and she came across like a few mistakes. So I have a feeling that this might be a mistake, because the answer they have that's right is 0.9025.
All right. And where's it at? Where's the problem at? Is it in that homework?
It was on the homework. I just don't know what problem it was.
Let's see if I'll see if I see something that's similar. Usually, though, when they make mistakes, it usually well, I'm not going to say that's not true, but oftentimes they do have mistakes. I haven't run across since they did this new iteration that came out of and almost a year ago. They redid everything to where it was students could use it with mobile apps, and so
and it's really bothering me because I put that answer. That's when I took a picture of it, because I was just practicing it on the weekend just to remember how to put it in the calculator.
like I said, I wanted to just make sure and see the question.
It's the one with Google. It says at the top.
Well, the thing is that they're in a queue, so it may not be the same problem. Is it in the quiz or in the homework?
No, it was in the homework.
All right, so the first 4 or 5 are that okay, multiple choice test. So the first one, so they're essentially giving you the P and the okay, of all the registered automobiles at the city, 7% failed the emissions test, 13 are selected at random. So it's not that.
I just put it on the little thing that you gave us, and that's not even like a
okay. Here we go. According to a recent report, 66% of internet searches in a particular month use a Google search engine. Assume that the sample of 9 searches is studied. I'm sorry, 20 searches is studied. Round the answers to at least 4 domestic. What is the probability of exactly 3? Let me do this one real quick and see if I can find a mistake in it.
Okay.
Because usually, if you get the same one, they will have the mistake in all of them. I remember, but it was with the old system. If there was a problem, if there was an issue with like a mistake, it would only show up like every fourth one or something like that. But 17. All right. So I was trying to do this fast, but accurately, so I can just see if. All right. So exactly 17. And they're asking for 4 decimal places this time. You got to watch that, all right? But that doesn't seem like that's your issue. Oh, you got to answer all of them at the same. So 12 or fewer. So that includes 12. So the only thing that's going to change is the number of successes. So more than 17. Oh, I forgot to pause the recording. All right, and then fewer than 9. Oh, it's just asking about whether it's unusual. All right, so I'll just go back and show you. I didn't show you why I was doing it because I didn't want to embarrass myself. I made a mistake, but I got them all right. So let's just see. It's not going to be the exact same ones, but usually if they've just changed like a little thing, like in this, they changed the percentage to 0.66, and then they just changed the n. So which was the one that you missed, that you got the wrong answer on?
Well, that's what's confusing me really like the most is because I didn't get it wrong. I put the right answer, and that's what's bothering me is because I can't give the right answer again. The answer they gave is 0.90.
Well, which problem was it?
It was
A, B, C?
What? I'm
was
sorry.
it A, B, C, or D?
It was the part 3. It was the more than.
Okay. So then they said more than what? 17? What was the value that they used?
They used 18.
All right.
I'm going to try it with your question.
You mean that program? Or
No.
yeah, okay, I got you. Yeah.
The question you gave me.
So more than 17. So this would be more than, like I said, I almost have to write it out because my brain is getting fried here, but it's 1 minus, because it's not included in 17. So it would be 1 minus probability binom prob CDF 17, and you would use 17.
What was the number of trials?
It's 20.
You got. Yeah, see, that's what I got. So it had to be a.
Well, it could be. It's just usually if there is, it'll you'll see it in more than just one problem, but that doesn't necessarily mean that has to be.
Yeah.
All right, so
just now for testing purposes, that's how we do it though. We do 1 minus the CDF and the number, whatever, if it's less or whatever like that.
well, I don't know when you'd ever use the 1 minus PDF. You use the CDF. I thought you said PDF, but the CDF, you got to use the CDF for when you're calculating a whole range. Okay. Now there is a situation where you could use 1 minus PDF, and that would be for the at least. So you could just do the none, the 0 with the PDF, but both would give you the same thing. Both the PDF and the CDF would give you the same thing anyway. But so anytime you got a more or a less or fewer or greater than, use the CDF. The only time you ever use the PDF is when it says P is equal to something or exactly.
Okay.
Because, for example, let's go back and look at this other one. Just to show you. See, there were some that are kind of already set up for you. This is not one of. Oh, that's just 14 or more. There was one. See, like for this one, it doesn't say exactly 4, but that's what that means right there. When you have for A, it says P of 4.
Okay.
That means exactly. So this won't let me select it, but that means the same thing. That means, you putting in only 4. And then for B, you're using the more than 2. So that would be 1 minus, and then you would do 0, 1, and 2. So you could put 2 in, 1 minus, and use the CDF with 2. All right, anything else? I'm getting tired here. I don't know what's wrong with me. I'm not feeling too good this week. Last night I barely made it through my class. I forgot to turn off the recording when I went to break.
Well, I hope you feel better.
Yeah, me too. But because I got to get up early in the morning and finish with his grades. And so what I'll do is when I'll just get up in the morning and make sure everything's right. And then they want us to put in the midterm grades, I think by noon. So
the grade for the last test?
It'll include everything up to this point, What I got to do, I got to bring over the homework and the quizzes scores and put it in I'll do it in the Canvas grade book. And hopefully, I don't know why it's not registered now, but because I don't see anything under final grade on here, like the total. No, there is a total. It's just that since there's 0 in for the Connect Math stuff, it's just not accurate. So anyway. And then, like I said, they want us to put in a physical letter grade into Canvas. Not a Canvas, into Lola.